Question 2. Given that g dash x equals f of x, we can say that g of x will be equal to the integral of f of x. Now, that probably means that g of x will be equal to x to the power of 4 on 12 plus x squared on 2 take 2x over 3 plus c, because we've been given some information about g of x, but we should probably check that on our class pad. That's not quite the form we're looking for, but if we expand that, we do indeed get the information that we've been provided. However, the integration constant still needs to be determined. As g of 0 equals 1, and this is polynomial, g of 0 equals 1 implies that c equals 1, which gives us our constant of integration, and therefore g of x as required. In A part 2, we're asked for the values of x for which the function g of x has a stationary point. In other words, we're asked, when does g dash x equal 0? Given that g dash x equals f of x, this means f of x equals 0. And looking at f of x above, we can see, as in factored form, that x will be equal to minus 2 or equal to 1. B part 1. Find the coordinates of B. B is the y-intercept of the line y equals 3, take 4x over 3. Therefore, its coordinates must be 0, 3, the y-intercept of the tangent. B part 2. The line AC is normal to the curve g of x at the point A. So we can find it on our class pad. If we use the previously found g of x, but make sure we add in the constant of integration, we can calculate the normal. At the point where x equals 2. Hence our answer is y equals 3x on 4 minus 7 on 6. As our point C is the y-intercept of this line, our C has coordinates 0, minus 7 on 6. B part 3 asks us to find the area of the triangle ABC. As we know the coordinates of B are 0, 3, we know the length OB is 3, and similarly we know the length OC is 7 over 6. We also know the coordinates of A are 2, g of 2, which means that the perpendicular height of this triangle viewed thus is 2. With this information we can easily find the area of the triangle. BC is equal to 3 plus 7 on 6, which equals 25 on 6. Therefore the area is 1/2 by 25 on 6 by 2, which is of course 25 on 6 square units. C part 1. To find the coordinates of D, we can use the fact that it is parallel to the tangent at A. In other words, we know that the derivative will have a value of minus 4/3, the slope of the tangent at A. And we can find the values of x for which this is true on our class pad. Selecting our previously entered value of g dashed as provided, setting it equal to -4/3, and solving. This gives us the answers x equals -1 and x equals 2. Now x equals 2 is the coordinate of the point A, therefore we're interested in the point x equals -1. To find the y coordinate, once again we can use our class pad. Selecting G, we get a y coordinate of 25/12. To find the length of AE, we need points A and E. To find E, we can find the tangent line DE. The point D has x coordinate -1, so we have our tangent line DE To find E, we need to find where this line meets the line AC. Here's our line AC. By equating and solving, we have the x coordinate of the point E. To find the y coordinate, we use DE where x equals 23/25. And we have our y coordinate minus 143/300. Point A is on AC. We know it has x coordinate of 2. And hence it has a y coordinate of 1/3. So the distance AE can be found using the user-defined function distance. Our points are 2, 1/3 and 23/25, -143/300. Giving us our distance of 27/20.